going to practice today doing some open and closed manometer problems. So you can find this worksheet on your class page, your choice, either print it out or you can upload it to your iPad and work from there. All right, so we're going to start with the first problem here. An open manometer that they're describing. So let's just do a real brief sketch here to help us think through on the open manometers since they're a little harder. And I'm going to have this side connected to my gas, and gas will be pushing there, and we're going to have this side open to the air. So it says that the mercury is 12 millimeters higher on the side open to the air. So that means if we were going to sketch this, it would look something like this. So this would be our H value. And what we need to decide is who's pressing harder, the air or the gas. Well, if it's going up higher in the side open to the air, it's because the gas has a higher pressure and is pushing the mercury up on this side, so that we see here that the pressure of the gas is greater than the pressure of the air. So remember from yesterday's lesson, we said that when we're finding manometer, we're always going to start with the pressure of the air and then decide whether we need to add or subtract that H value. Since we need a bigger number, gas is higher, we're going to add H to it. So they gave us the atmospheric pressure here is 100.8. So our pressure of our gas will equal 100.8, and that was kPa. And we're going to add to that the 12 millimeters of mercury, which is our H. Okay, we have two different units, so we have to get them the same. We'll change our millimeters of mercury to kPa, and that would be 12 millimeters times 101.3 kPa over 760 millimeters of mercury. So 100.8, and we get out our calculators. 12 times 101.3 divided by 760. And we want to round that to 2 digits because of the 12 millimeters of mercury. And that gives us 1.6 kPa. It's about 6 kPa. And now our adding rule, they both have 1 decimal, so we're going to add them together and round to 1 decimal, and we get 102.4 kPa for our final answer to the first problem. Okay, so let's scroll down and find a closed manometer problem. And we like those because they're a whole lot easier. So it looks like problem 3 here is a closed manometer. So closed manometer is simple because H is our pressure. It's a direct reading. So we like when we see the closed manometer. So the pressure of the gas equals H. And in this case, it is 521 millimeters of mercury. Okay? If that was the only question, we'd be done, but it says, what is the pressure in torr? Well, that's great because we know from looking at our conversions that 760 millimeters of mercury are the same as 760 torr. We really didn't need to write this, we're just doing it to show how units would cancel. And we are going to get 521 torr as our answer. All right, so I did those two. You're gonna complete the rest of the problems here on the worksheet. And then if you could please load them up to the Dropbox that I have set for you, we're great for today. Okay, see ya.